Hello, good morning, good afternoon, and good evening. Today, I would love us to work out the tutorial sheet on exponential and logarithm tutorial sheet for Ma-110. So, this basically is for Ma-110 students from non-quarter School of Mathematics and Natural Sciences. So we're looking at a tutorial sheet on exponential and logarithm functions. So I'm sure you all have the tutorial sheet. Yeah, and I'm sure I don't know if it will be visible through this video on my laptop there, where I've just displayed it on the laptop. So we'll follow through. So basically, for you to understand fully this video, you're supposed to first of all to understand the introduction videos. So there are two links there: the intro on exponential functions and the intro on logarithmic functions, so that you understand the meaning of an exponential function and understand the meaning of a logarithmic function, as well as understand and be able to look at the rules and properties of exponential and logarithmic functions. Very much important, because it will all be solving all these questions based on the rules and properties. Okay, so let's start with the first question given there. So the first question says that solve the equation 2 power 2x plus 1 minus 15 power 2x minus 8 equal to 0. That's our first equation which we are having there. Solve the equation. So basically, if the question says solve, we are simply trying to find the value of x. So let's find the value of x, and after finding the value of x, it means that we have solved the equation given. So what are we having there? First, understand what kind of an equation do you have there. So the way it is set up, you should be able to understand that number one, that is an exponential equation. Why is it an exponential equation? The power is a variable. So it means at least here what I need to understand is I need to be able to bring down, or maybe bring in, the concepts of exponential rules. So with the concept of exponential rules, this can be written as 2 power 2x multiplied by 2 power 1. So if I'm multiplying the same bases with different powers, it is just as easy as embracing one base and raise it to a summation of those powers. So basically 2 power 2x plus 1 is the same as 2 power 2x multiplied by 2 power 1. This remains the same. 2 power x minus 8 equal to 0. The greatest mistake, or the biggest mistake you are going to make, is you multiplying 15 times 2, which is very much wrong. So these two cannot be multiplied because 2 is raised to a power of x, which is a variable which is unknown. So if we were to evaluate this 2, the first evaluation to be made, it is 2 power x. After evaluating that value, that's when we multiply by the 15. So if that evaluation is not yet made, it means that these two can never multiply. So let's still break down this. This is multiplication. Multiplication is commutative. Even if I was to start with 2, there's no harm. So 2 can come first to become 2 multiplied by 2. The power 2x can be written as x squared. There's no harm. Remember the property, you are simply saying x times 2 is the same as 2x. So I want the 2 power x here, so that, in short, what is happening here is that in this equation, if you have any equation which is in this format, your aim, it is to make sure that what you see here should also be visible there. So no wonder I'm trying to break down the 2 power 2x to be 2 power x multiplied by a 2, so that from there we can have minus 15 2 power x minus 8 equal to 0. Now after having something like this becomes very much simple now. How is it very much simple? Because I'm able to simplify it by simply saying, what if I let my 2 power x to be any letter of my choice y? This becomes 2y squared minus 15y minus 8 is equal to 0. This means that I am now solving for what? For x, I mean for y. After finding for y, we'll come and replace in this situation to solve for x. So this is very much simple because it has now become as a quadratic function or equation. So let's solve two numbers which can, when we multiply, they'll give us a negative 16. When you add, they'll give us a negative 5. What numbers are those? We're going to have 2y squared 15, for me to have 15 and for me to have negative that, this is basically negative 16y plus y minus 8 is equal to 0. So these are the two numbers, 16 and positive 1, implying that we can factor by pairs. I'm going to have factor this to be 2y open bracket y minus 8, and here we still have positive y minus 8 is equal to 0. So if that is the case, it means that the two values of y we are going to have will be 2y plus 1 is equal to 0 and y minus 8 is equal to 0. We are okay? So from there, what am I going to have? We are now going to have these two values. So this is what is going to happen now. I'm now going to have 2y plus 1 equal to 0, implying that if I want to find the value of y, this will be 2y is equal to negative 1 over 2 over 2, and the value of y will be equals to negative 1 over 2. This will be my first value of y. Next, we equate this y minus 8 to 0. This becomes y minus 8 equal to 0, implying that y is equals to positive 8. This is another value of y because it was a quadratic, remember. So what comes next? Recall that your y was equal to 2 power x. So we are going to equate both of them. So it means that the first one is negative 1 over 2 to be equals to 2 power x, and the other one is 8 to be equals to 2 power x. What will be the value of x? Now, according to exponential rules which we know that any function which is an exponential function in this format, this can never produce a negative value. Remember, the range of values for an exponential function is only value from y greater than 0. So it means that this function here is basically invalid. This function is undefined. The only defined solution will come from this guy. This will be the one which should be defined, because the range values of y should be greater than what? Should be greater than 0. We're interested in y values which are greater than 0. So this y is negative, so it cannot define our exponential function. So therefore, if we break down this can be written as 2 power 3 to be equals to 2 power x, implying that the value of x is going to be equal to 3. As simple as that. So we have solved the first equation of our tutorial sheet. So basically we are still all using just the properties, the rules and everything. Let's go to the second one. We're now looking at the second part. The second part says that solve or find the value. Find the value of what value are we looking for? We are finding the value of log 4 base of 4 8 root of 2, and the second one is find the value of log base 5, this is 49, and then this is being multiplied by log, is this a 7? Yeah, 125. Find the value of those two expressions. That is our M. So basically when we want to find the value of logs, and again what should come in our mind is all the properties of logs and all the properties and rules of logarithmic functions. You can't solve if you do not know those properties or rules. So let's now start finding the values. So what do I have here? I have that log base 4 8 multiplied by the root of 2. So here we just have to apply the properties. I'm seeing that this is the base here is 4 and the input here is a multiplication of two values. So for me to simplify log 4 8 root 2, this can be broken down according to the multiplication principle which we talked about in previous videos. To say if I have log b x y, the multiplication here, this will lead us to what? The log of b x plus the log of b y. So I'm going to use this property to break down this. So this is just going to be written as the log of 4 8 plus the log of 4 root 2. We are okay? So now remember, we are just using all the properties we know in mathematics or in logs. Now in evaluating this Ma-110, we don't have calculators, so we have to use all the properties as possible to make sure that this answer is evaluated. So what am I going to do? Log 4 8 like this to be very difficult to evaluate. So the easiest for me to make sure that I can be able to evaluate this is to use basically some properties. So I have to make sure that maybe the base and the input should be the same for this guy to be evaluated. The base and the input maybe should be the same for that guy base to be evaluated. So let me express everything on base 2. What am I going to have? Log 4 8, this can still be written as the log 4 can be written as 2 squared. 8 can be written as 2 power 3 plus log 4 can still be written as log 2 squared. Root of 2 can be written as 2 power 1 over 2, which is very much correct. And we know that the property which we are using here, we know that the log of a certain base b, and in the input here I have a b which is raised to a power n, and the base here is raised to a power m. This is just equivalent to n divided by m. That property, I'm sure we talked about it obviously in maybe the previous video. So log the base of b power m and the input of b power n, it is just equivalent to n divided by m. We're okay? Yeah. So this is what I'm going to do on both cases. So this means this is just basically equal to what? So since this base and the input are the same but different powers, it is just basically the same as the first one here. I'm going to have 3 over 2 plus the second one here, it will be 1 over 2 divided by a 2, because the power here is a 2. So simplifying everything, this will be 3 over 2 plus 1 over 2 multiplied by 1 over 2. this is going to be equal to 3 over 2 plus 1 over 4. We are okay? So that by the end of the night, what am I going to have? 3 over 2 plus 1 over 4. This is just equivalent to what? Lowest common denominator, it's a 4. 2 into 4 is 2. 2 times 3, 6. 4 into 4 is 1. 1 times 1, it's 1. So that we can have x plus 1, 6 plus 1 is 7 over 4. It means that our final outcome, once this is evaluated, the value for log 487 over 2 is equivalent to what? 7 over 4 as our final expression, final value. You okay? Now let's look at the second part. Let's look at the second part. This can go. Let's now look at the second part. Let's find the value of that. Let's find the value of that. So I want to find the value of log base 5 49. Your answer to be multiplied by the log of 7 125. Now remember, as usual, because you cannot evaluate something if you have different bases, it will be very much difficult. So the easiest, it is to make sure that you convert everything to equivalence to one base. So if you wish to evaluate that, you can convert everything maybe to base 5 or maybe just to base 7, or just eventually we are talking about trying to solve with just a unique base. Here base 5, here base 7. So evaluation in this case will be a little bit tricky. So what do? I have to try by all means to convert everything to a unique base. And if you have bigger eye, you will be able to see that I think the easiest here, we are going to convert all to base 10. That's the easiest. So converting this conversion property, what are we simply saying? Look at the previous video. Now we talked about converting from one log to another. So log of 549 can be written as the log of base 10 49 over the log of 5, like that. And log 7 125 can be written as the log of 125 over the log of 7. This is what we have. So let's now combine them together. This implies that what we are solving for log 49 over log 5, which is this guy, multiplied by log 125 over log 7, which is this guy. Let's simplify everything. This implies that the 49 can be written in the form of log 7 squared. 7 squared, we know that will give us a 49 over log 5, multiplied by 125 can be written as log of 5 power 3. 5 power 3, we know that this is 125 over log 7. So what is going to happen here, from the power rule, the powers can drop down. I'm sure we are familiar with those rules. The powers will drop down. Eventually, what are we going to have there? We are now going to have 2 log 7 over log 5 multiplied by 3 log 5 over log 7. This is multiplication. It means this log 7 and this log 7 can go. This log 5 and this log 5 can go. Remember, we are remaining with 1 here, 1 there, and 1 there. So it means this is just a matter of you multiplying 2 multiplied by 3. It means that the final outcome you're going to have is your 6. So this evaluation here is going to be equivalent to what? To a 6. As simple as that. So from there we can now shift and talk about the next questions. Okay, so let's go to the next question now, which is question number 3, which deals with sketching of exponential and logarithmic functions. Now, we talked about a number of rules of exponential functions and a number of rules of logarithmic functions. So every function, once sketched, you are going to have a certain specific graph which is going to come out. So number 1, let's look at the properties of an exponential graph. So we have to understand some of the properties of an exponential graph. So when it comes to exponential graphs, we have to understand that number 1, all exponential functions, these all exponential functions mean that an exponential function in the form of f of x equals to a power x are continuous, passing through 0, 1. That's the first point you're supposed to be able to understand. So all functions which are exponential functions, they are continuous and they will always pass through at 0, 1. Next, we have to understand that this function f of x equals to a power x have what is known as a horizontal asymptote. Horizontal asymptote, and this horizontal asymptote is a line which is called y equal to 0. It's a horizontal line passing through at 0 on the y-axis. It means that this line which we're talking about being the horizontal asymptote, it is a line, once it is drawn, it is more like giving a demarcation. This line y equal to 0, straight line y equal to 0, is giving a demarcation to say the graph which you are going to sketch, because an exponential function being continuous can be either in this manner or maybe decaying in that manner. So it's the demarcation to tell you to say that this graph, when it is continuous, it will not protrude to go to the other side. It is just getting attracted to this y equal to 0, but will not cross over to the other side. It's a demarcation showing you to say the function f of x equal to a power x is only defined on this upper region or on this lower region. So that's what the asymptote talks about. So exponential functions, they have the horizontal asymptote. What kind of horizontal asymptote? The initial horizontal asymptote talking about it is y equal to 0. Next, we have to understand that if we are looking at an exponential function f of x equal to a power x, this function is an increasing curve if the a is greater than 1. So basically, if maybe I have 2 power x, 4 power x, 5 power x, 3 power x, anything, as long as this a, which is my base, is greater than 1, I am expecting to have an increasing curve. And a decay curve or a decreasing curve if the base is a fraction. So if this a is in between 0 and 1, the a is basically a fraction, I'm expecting to have a decay curve or a decreasing curve. So what is happening there? I'm going to have, if this is my Cartesian plane, what is going to happen is that the function can either be increasing in this manner or the function can either be decreasing in that manner. So this function f of x equals to a power x will be increasing if this a is greater than 1, but to be decaying if this a is what? Less than 1. So if a is greater than 1 and if a 0 is less than a and a is less than 1. This is what will be happening. So even as you'll be sketching a number of functions, at least even before you sketch, you can even be predicting the nature of your curve. Slightly, you'll be able to predict, to say, okay, I think basically my nature of the curve which is going to come up will be an increasing curve or a decay curve. Even the domain, what is going to happen to the domain? The domain is basically all real numbers in both exponential functions. But for the range, it is limited to the what? Asymptote. This is your asymptote, y equal to 0. So basically, the domain here is basically x being all real numbers. But for the range, we're just talking about y being greater than 0. That is what is going to happen. Yeah, okay? So now, if this is the case, the question is, how do we sketch exponential function? So we are going to sketch these exponential functions. We are going to sketch these exponential functions using transformational rules, which we are going to use in this question. So let's use the transformational rules. Remember the transformational rules which we were applying in term 1. So let me just, I'm sure I've drafted down the properties of exponential function. Now let's look at what should be able to be happening when sketching this exponential function. So now we know that the original function for an exponential function should be f of x to be equals to a power x. So this is why I should be able to tell how your function should be transforming or shifting eventually. So what is going to happen here is, if I have x plus k and if I have x plus h, okay, let me say this is h and this is k. So there can be two possibilities there. So we have to understand, if any function is in this format, the original function was a power x. So it means that the shift which is going to apply to this function, it means that for me to have f of x, the outcome is starting by transforming the a power x. So basically, f of x is made up of what? So for this function to be made up, it is first of all making up, or maybe we are going to have y to be equals to a power x, shifting h units to the left. This is a horizontal translation. This is a horizontal translation. So anything which happens to the power, we have a horizontal translation happening there. So this is our horizontal translation. Anything happening to the power is a horizontal translation. So it means that this function f of x is undergoing a shift in the horizontal, shift h units to the left. If this was a negative, it would have been shifting h units to the right. It always does the opposite of the what? Of the sign. Okay? So, if that is the case, this y equals to a power x will produce this y. So this shift will produce a power x plus h. And then the plus k here, what does it mean? This plus k, it means it is a vertical translation. We are just trying to remind ourselves in term 1, because we talked about transformation rules in term 1. So this in the x is a horizontal translation. In the y, a constant value is a vertical translation. So it means that the translation you are going to have for this guy, it is an up or down translation. So what am I expecting? I'm expecting if I have this k, it means that if I have y equals to a power x plus k, this means that, or maybe I can simply say y equals to a power x. This is a shifting k units. So y equals to a power x shifts k units upwards. So the shift k units upwards symbolizes that what are you having? You are simply having a power x plus k. So if you have a plus k constant plus as a constant to your exponential function, that is your vertical shift upwards. So the vertical shift always obeys the sign. If it is positive, it will be upwards. If it is negative, it will be downwards. We are okay? So what are we simply saying? If I have a x plus h, this is basically a horizontal translation. But if I have a power x plus k, this is a vertical translation. So if this was a negative, it would have mean it would be shifting what? Downwards. So these are the two key major things for now. And then later there will be reflections and the like, which we'll be talking about, which we'll look at them later on. But now let's just try by all means to focus on these ones. Example. Let's look at sketching sketch the following. Sketch the following. So we are going to sketch y equals to 3 power x plus 1 minus 2. We want to sketch that. So using my transformational rules, it means that this function came from what? So steps, which we are going to sketch with. Steps, sketch the original y equals to 3 power x. And this transformed to become y equals to x plus 1. After that, it will transform to become y equals to 3x plus 1 minus 2. Then we've reached the final function. So since this is a transformation method, this one will be dotted curve. This one will be a dotted curve. But this one will be a full curve, symbolizing that we have reached what we are looking for. So every time we are trying to sketch any function, we always start by looking at the horizontal translation first. All translations which is happening in the x, we deal with them before coming with the translations which are happening in the y. So we have to note something. The base is greater than 1. So if the base is greater than 1, what should happen? Then it is an increasing curve. It is an what? Increasing curve. So let's sketch. What am I going to have if sketched? So if this is my Cartesian plane, so what am I having there? X or y. We start first of all by sketching the parent function with e power 3x. So the e power 3x is going to be a function which will be dotted continuously since it is greater than 1, it will be an increasing curve. But if this 3 was less than 1, I couldn't have started by an increasing curve. I could have let it be what? A decreasing curve coming like that. Remember from the properties of an exponential function? So this is basically 3 is greater than 1, implying that it is an increasing curve. So if it is an increasing curve, this is how my increasing curve should be able to look like. So it is always passing through at what? 0,1. The properties of exponential graphs. So this would be f of x equals to 3 power x. Now we go to the next stage. We look at the power. Is there anything which is happening to your power before you go to anything which is down? So you look at the power. Yes, there's something which is a plus 1. It means we have to sketch 3 power x plus 1. So the plus 1 is a horizontal translation. So if it is plus, it is going to the what? The negative. So all the points should go one step to the negative direction. The only point we know right now so far, it is 0,1, which is this point. Let's shift this point one step to the left. So from 0,1, one step to the left, how am I going to stand? I'm going to stand at this point, which is what? Negative 1,1. So it means that if this function is going to shift one step this side, it's the graph, instead of passing at 1,0, it's going to pass at negative 1, what? 1. Well, okay? So it means that it is going to cut the y-axis at what? When x is 2. So when x is 0. And when x is 0 here, put a 0 there. What are we going to have? It's going to cut at, put a 0 there to be 3 power 1. It means that it's going to cross at 3. So this will be f of x equals to 3x plus 1. When x is 0, it means that it is cutting at 3 there. Remember, that is your what? Your y-intercept for this function. And with this point, which is the negative 1,1. And lastly now, but not the least, the vertical translation, which is negative 2. So negative 2, it means that all the functions should move 2 steps downwards. It's a vertical translation. Remember, starting with your asymptote. The asymptote here was y equal to 0. That was your asymptote. But when shifting the vertical, when shifting the x, the shifting in the x, the vertical, the horizontal asymptote. The horizontal asymptote, when the shift in the x was happening, it wasn't changing. Either you move it to the left or you move it to the right, it will still be y equal to 0. But this horizontal translation, when the horizontal asymptote will only change if there is an upward or downward translation. So y equal to 0 will change if these functions are shifting maybe some steps downwards or some steps upwards. So since there's a negative 2, it means that everything moves 2 steps downwards. Instead of the horizontal asymptote being y equal to 0, it will move now from 0 to negative 1, that's 1 step, to negative 2, that's 2 steps. It will be at negative 2. So the horizontal asymptote, it is this line now, which is y equals to negative 2. In brackets, put in, say, horizontal asymptote HA. Every point, this point was at negative 1,1. It is moving 2 steps as well. So from negative 1,1, it will be negative 1,0. The other step will be negative 1, what? Negative 1. So it is going to pass through at this point. Well, okay. And then next, we are looking at the 0,3. 0,3. Yeah. 0,3 was here. So it is moving 2 steps downward. One it will be at t 0,1. The other step will be at t this point 0,0. Implying that the function, as it was getting attracted to asymptote increasing, it will pass to this point, pass to 0,0, and increase in that direction. So what am I going to have? This is my final function now. F of x to be equals to 3x plus 1 minus 2 as your function. In case the question says find your domain, the domain of all these functions are always all real numbers. So the domain will be always x being all real numbers. But for the range, the restriction comes in for the what? Asymptote. The asymptote is negative 2. It means that the range is y greater than negative 2. Or if you want it, you can be y negative 2, positive infinity, like that. And this one is negative infinity to positive infinity, like that. We've sketched one function. We are okay? So, number one, break it down from the parent function to the power. So from the parent function 3 power x, that's the original function. Then go to your power. If the power has something, then focus on translating what is in the power. So in the power, it is a horizontal translation. If it is plus 1 like this, it is 1 unit to the left. If it was negative 1, it would be 1 unit to the right. After you are done with the power, go to your constant value, which is minus 2. The minus 2 means 2 units downwards. So this constant always obeys the sign. If it is negative, it is 2 units down. If it is positive, 2 units up. We are okay? And then, after you label your steps like that, now be able to observe your base. If your base is greater than 1, which means that it will be an increasing curve. Only the increasing curve will be the one which will be transformed. If your base is 1 over 3, you start with the 1 over 3. It will be, maybe if your base is a fraction, you start with that fraction, it will be a decreasing curve. Then that decreasing curve is the one which will be transforming in other types. Let's look at the second part B. Look at the second part B. Now let's look at the other part. So we have been told that sketch f of x equal to 1 over 3 power x minus 1. So number one, the base, we'll look at the base. The base is in between, the base 1 over 3 is in between 0 and what? And 1. So what do I expect? The function to be what? A decreasing curve. So I'm going to have the steps which I'm going to sketch are, number one, we have to do 1 over 3 power x, which is the original function, parent one. From there, we'll do the translation which is happening in the power. So everything in the power, it means it's a horizontal translation. We'll do that one. And lastly, we'll do 1 over 3 x minus 1 plus 2. Okay, so from there, yeah, let's sketch. This will be dotted, this will be dotted, this will be a full curve because it's a final function. Okay, let's start. So this will be my Cartesian plane. So if this is x or y, we start 1 over 3 is a decaying, it's a base is less than 1, so it's a decay curve. So it will be decaying, passing through at what? Something like that. So it's passing through at 0, 1. Next, minus 1. What does it mean? The minus 1 in the power means 1 unit going to your positive x-axis. So if I'm at 0, 1, we are now moving 1 step up. I'll be at what? 1, 1, this point. We are okay? So it means that as the function is coming decreasing, it should come and pass you at this point. It means it will no longer pass you at 0, 1. Okay, there is a shift. So this one is f of x equals to 1 over 3 power x. But the next one will be, as it is decaying, will be decreasing. Then we are going to have what? So we're going to have it being passing there. So number one, where is it going to cross in the y, in the y-axis? When you put x with the 0 there, it means that it will be minus 1. 1 over 3 power negative 1, it means it's going to cross at 3. So it is coming there, crossing at 3, and then getting attracted to the asymptote. It means that this point where it's going to cross at should be at 3. And you label it as f of x to be equals to 1 over 3 power x minus 1. And last but not the least, since we are done with this one, we go to the last one now, which is the plus 2. So the plus 2 is an indication that everything should move 2 steps upwards, starting with the horizontal asymptote. Since the horizontal asymptote in the first place, it was y equal to 0, so this shifts to 2 units. So the first one will be at 1, the other one will be at 2. So if this is 2 here, then the line is going to cross at what? 2 on the y-axis there. This is the y equals to 2 as the horizontal asymptote. The next point, 1, 1, will now move again 2 steps. 1, 2. It will now be at 1, 3. And this point, 0, 3, will now move 2 steps. 4, 5. 4, 5. It will now be at there. So it means that the function is coming qua, pass through at there, getting attracted to the asymptote in that manner. So this will be the new function now, which is f of x to be equals to 1 over 3 x minus 1 plus 2. As simple as that. What is the domain and the range? The domain is always all real numbers, but for the range, the domain is always all real numbers, but for the range, always comes from the asymptote y greater than 2, implying that y is member of 2 to positive infinity. This one is y member from negative infinity to positive infinity. Like that. So, number 1, look at the base. If the base is a fraction, not say we start with a decreasing curve, then the other transformation should be happening, will be applying to that decreasing curve. If the base is a whole number which is greater than 1, if the number is greater than 1, we start with an increasing curve. Anything which will be happening to the increasing curve will be transformations which will be happening for that function. We are okay? So the next part, we'll now look at the logarithmic graphs. The logarithmic graphs. So that will be in the next video, the logarithmic graphs. But the one you can go with, the next question on your tutorial sheet, please be able to sketch f of x to be equals to e power x plus 1 minus 3. Kindly sketch this one for me, for us. E is not a variable, e is a number. E is an irrational number, approximately 2.7 continuous. So this is an exponential number. So it means that what kind of a curve do you expect this to have? If it is e power x plus e is a base greater than 1, it means that the first thing you're supposed to do, it will be an increasing curve. That increasing curve will be transforming. Yeah, okay? Yeah. So with that being said, let me end this video here and see you in the next video, which will be talking about the sketching of logs. Thank you very much.